friends, it's time for another Friday Fun Fact, where I'll share a little tidbit of information that you might not have known before. I don't know about you, but it's not July 4th quite yet, and I'm already hearing fireworks at night. So let's investigate. How exactly do fireworks, well, work? Before we do, obligatory warning. Don't try this at home. If you find this super interesting, pyrotechnician and pyrotechnic chemist are jobs that exist and that you can work towards. Stay in school and your job someday could be to make things explode in fun ways. Fireworks originated shortly after the invention of gunpowder in China and had reached Europe by the Middle Ages. So we've been exploding things for fun for quite a long time. But let's take a look inside the explodey bit, where all the fun actually happens. Within the central tube of a firework is packed gunpowder, explosive stars, and a fuse. These stars are what actually creates the firework. They're made of an oxidizing agent, fuel, metal salts for color, and a binder to keep it all together. Once the spark is lit, the oxidizer and the fuel produce light and heat, causing the metal salts to burn in colorful ways. Once all the fun stuff is in the firework shell, that goes into what's basically a mortar tube that's been partially buried in sand. There's a lifting charge in the bottom, so when that's lit and ignites, it sends the firework shell flying up into the air. The fuse within the firework is on a delay, so the firework won't explode until it's far enough up. Then that explodes, the stars ignite, and you see the beautiful result. It's the composition of the star and how they're packed within the shell that changes how the firework looks. If you want a specific shape, you arrange the stars in that shape, so that when it explodes, the stars will fly outwards in that pattern. Where it really starts to get sciencey, even more so since we've already got physics and engineering down, is with the metal salts. You see, different chemical salts burn different colors. For example, to get the magnificent blue color you see, you need to heat copper up, which is apparently super hard as the copper compound used isn't super stable at high temperatures. For white or silver, you use aluminum, and for green, you use barium. Here's a chart of a bunch of colors from an article courtesy of the American Chemical Society. This is an example of luminescence, as opposed to incandescence, which of course fireworks also do because the compounds get so hot. So, as you can see, tons of science goes into these wonderful displays of light. If only they weren't so loud. Fun fact, the sound you hear is actually a supersonic boom created by the rapid expansion of gases within the firework as it explodes. No wonder dogs hate it. Our dog always tries to hide in my closet when firework time rolls around. Poor Oreo. My citations are below, and if you'd like to learn more about chemistry, check out these books from the library. Like and subscribe for more Friday Fun Facts, and I'll see you next time.